Hello and welcome to the 10th and final tutorial in this rather long series on trigonometry. So congratulations if you've stuck through it all the way to this 10th tutorial. I do hope that you have found this helpful. You can see it's quite a big topic. It has various parts to it, and these last two pieces we've been covering, the graphs of trigonometric functions and trigonometric equations, are probably amongst the hardest material that you study at this sort of National 5 O-level type part of maths education. So if you are finding this tricky, don't fret. I can see I finally fell at the last hurdle and misspelled trigonometry. Trigonometry. Right. We're going to just show in this last tutorial an alternative method for solving trigonometric equations. In the last tutorial, I solved a bunch of examples using a graphical method where you just make a sketch and sort of use knowledge of symmetry to infer solutions. There's a more modern method which is a bit more algorithmic. I'm not quite so keen on it myself because I do feel that if one only knows that method, it's a bit handle turning, and maybe using it you don't have quite the strongest sense of why it works, but it is effective. I'm going to refer back to these graphs here from a previous tutorial to motivate the method. What you can see is that we can break up the range 0 to 360 into four sort of quadrants: 0 to 90, 90 to 180, 180 to 270, and 270 to 360. And what we do is we draw a picture of those four quadrants and we say which of these three functions are positive in each quadrant. Okay, so let me do that. So you make this sort of cross here. We're going to talk about these four quadrants, and we ask which of the three functions is positive in each quadrant. Now in the first quadrant, 0 to 90 degrees, all three functions are positive. In the second quadrant, only the sine is positive. Cos and tan become negative. So in the first quadrant then, we write A, which stands for all three functions are positive in that quadrant. In the second quadrant, we write S, standing for sine, that only sine is positive in that quadrant. In the third quadrant, only tan is positive, cos and sine are both negative, and in the fourth quadrant, only cos is positive, sine and tan are negative. So in the third quadrant we write T for tan, only the tangent function is positive in that quadrant, and finally in the fourth quadrant we write C for cos, only cos is positive in that quadrant. And so there's a little mnemonic here called cast, so one often talks of the cast diagram. We also draw an accompanying picture with the same four quadrants, and we ask what are the related angles. And so we basically say, if we have a solution of a problem in the first quadrant, but we know there's another solution in a different quadrant, how would we get that solution from the knowledge of the solution in the first quadrant? And this really is just taking advantage of those symmetries that we talked about in the last tutorial. Some of these might seem familiar, adding 180 or taking x from 360. And again, if I just show you quickly on here, but examples will be the best way to see this. But for example, we can see that for the sine function, a solution in the first quadrant would be equivalent to a solution in the second quadrant, but subtracted from 180 because of the symmetry here. Similarly, a solution in the first quadrant would be related to a solution in the last quadrant, but subtracted from 360. But you might say, but hang on though, the sign has changed, and that's exactly right. So these related angles tell you about related solutions, but they don't care about the sign, and that's why you need this diagram to help you get the signs right. So this diagram says which function is positive, and this diagram tells you what the related angles are that have the same solution regardless of sign. And using these two together, you can figure out pretty much what you need to know. So let's just do some examples and we'll see how this works. So let's imagine that we're solving the equation cos x is, let's say, 45 degrees. Okay, well we actually, oh, I'm being very silly here. I'm going ahead of where I want to be. I wanted to say 1 over root 2, and the answer to that is 45 degrees. So sorry, that was very silly. Let's say the equation is cos of x is 1 over root 2. Now we know there is a solution 45 degrees. And the question is, where's the other solution? And I'm not going to use a sketch, I'm just going to use these diagrams to work that out. So I'm dealing with the cosine function. It's equal to something positive. This diagram says, well, cosine is positive in the first sector. Yes, that's the solution I have there. It's also positive in the fourth sector. So I need to be looking in this sector here. And then this diagram tells me if I have a solution in the first quadrant and I need a solution in the last quadrant, I need to take my solution away from 360 degrees. So the other solution is going to be 360 degrees, take away 45, which is 315 degrees. So those would be the two solutions. I can just check that that's right. So 1 over root 2, let's just see what that looks like. That's 0.707 dot dot dot. And we can see if I take 45 degrees and the cosine, I get 1 over root 2. If I take 315 degrees and take the cosine, I get 1 over root 2. So all is well. Let's do another example. Let's imagine we're doing tan of x equals 2.7. Right, well, tan is positive. There will be a solution in the first quadrant because all functions are positive there. Tan is also positive in the third quadrant, so there'll be another solution here. So I can find the solution in the first quadrant by just using the calculator, typing in 2.7 and taking the inverse tangent, and I find a solution 69.7 degrees. The other solution will be in the third quadrant. I look at this diagram at the related angles and I see if I'm in the third quadrant, my related angle I get by just adding 180. So the other solution will be this plus 180. So that will be 249.7 degrees. Just check that. If I add 180, there it is, and I can just check by taking the tan, you see I get back 2.7. So if you're comfortable using this method, it does go fairly quickly. It's a bit trickier to use if you have negative values. So let's do an example with a negative. Let's say we have sine x equals negative 0.5, for example. Okay. Well, we're expecting two solutions. We're expecting where sine is negative, Well, sine is positive here and here, so sine will be negative here and here. So we want to work in the third and the fourth quadrants. But to use the related angles, we want to have a solution in the first quadrant. So what we do is say in the first quadrant, let's solve an equation that is the same but with a different sign here, because then we know it will have a solution. And we know actually the answer there is going to be 30 degrees. We can just check 0.5 inverse sine 30 degrees. So 30 degrees is the solution to this related problem where I've switched the sign. So this is not going to answer my problem, but it's going to give me an angle that I can then feed into the related angles. And the related angles are 180 plus this and 360 minus this. So 180 plus 30 degrees gives me 210 degrees, and 360 minus 30 degrees gives me 330 degrees, and those would be the solutions to the problem of interest where sine was negative and the answer we were seeking is in the third and fourth quadrants. And again, you can always just check your answers, and if there is an error you can go back and see where you may have gone wrong. So 210, take the sine, we get negative 0.5. 330, take the sine, we get negative 0.5. Let's just do one more example. Let's say we had to solve tan of x is negative 0.9, for example. So where is tan negative? Well, tan is positive in the first and the third quadrant, so it's negative in the second and fourth quadrants. So we're going to be looking in the second and the fourth quadrants here. Okay. But we need a solution in the first quadrant, and we're going to do that by sort of doing a pretend problem where we solve tan x is plus 0.9, and that will give us sort of the input for these related angles in the second and fourth quadrants. So solving tan x is 0.9, so we take 0.9 inverse tan, we get 41.98. That's a tricky one. Let me just call it 99 degrees for now, okay? Then the related angles are in the second quadrant, it's going to be 180 take away this value. And in the fourth quadrant, it's going to be 360 take away that value. And let's see what we get. So if I subtract this from 180, I get 138.0 degrees. And this one here will be 180 greater, which makes sense because we know that the solutions to tan repeat every 180 degrees. So these would be the two answers. And again, we can just check. So 318 degrees, if I take the tangent of that, I get minus 0.9. And 138 degrees, take the tangent, minus 0.9. So those are the examples that we have done using this method. It's pretty slick when you have a positive value. So these two examples went very easily. When you're dealing with negative values, so you have a trigonometric function equal to a negative value, you do have to kind of play around a bit with this method. But again, with practice it becomes relatively easy to use. So that is the end of this series on trigonometry. We've covered a lot of ground. I do feel the last few tutorials have perhaps not been as clear as some of the others, and I apologize for that if that is the case for you. Even so, I do hope that they are helpful, and you're always welcome to get in touch with me by email if you have particular questions. So we're going to move on now, and the next tutorials I'll be giving will be on, to be honest, I would say simpler topics. We're going to look at equation of a straight line, we're going to look at simultaneous equations, and then we'll get into a trickier topic again, which will be the problem of quadratic functions or parabolas, which is a very beautiful topic. Again, some students find it quite tricky. So thank you for your attention, and I'll see you next time.